So remember in video 8 or 9, I forget, whatever the last video was, and I told you that we would be meeting up together in chapter 5? Well, I lied. I remembered that we needed to cover one last category before we finish the chapter, and that's gas-forming reactions. So gas-forming reactions happen two ways, either by reaction with acid or by reaction with base. So if we react with acids, compounds that are sulfides, carbonates or bicarbonates, sulfites or bisulfites, when those react with acid, they will produce gas. Typically, depending on which thing you're reacting with the acid, you'll either get hydrogen sulfide gas, carbon dioxide gas, or sulfur dioxide gas. And then the only one that reacts with base is ammonium, in which case you get ammonia gas as a product. So let's look at how these reactions happen and see if we can sort of put together a mechanism to help you understand how this is going to work. So let's say I have, we're talking about sulfides reacting with acid. Okay, so if I have H2SO4, sulfuric acid, and I react it with some lithium sulfide, okay, an aqueous solution of lithium sulfide. My immediate product, all I do is a double displacement reaction, and I get H2S, which is a gas, hydrogen sulfide gas. And my other product is simply the salt, lithium sulfide, or lithium sulfate, excuse me. Okay, that one is just, you just kind of have to know that one, unfortunately. Now the carbonates, bicarbonates, sulfites, and bisulfites, there's actually a mechanism involved that will be easier probably to keep in your brain. All right, so let's take a look at if we react hydrochloric acid with some sodium bicarbonate, i.e. baking soda, NaHCO3. If I do a double displacement, comes out a bit interesting. So my sodium is going to go with the chlorine, like usual. Then my hydrogen is going to come over and hook up with that hydrogen. Okay, my bicarbonate, HCO3 is one of the polyatomics. HCO3 minus is bicarbonate. So my product there is H2CO3, carbonic acid. And it's aqueous. And then we also have our sodium carbonate, or excuse me, sodium chloride, wow, words are hard, salt. What happens with the carbonic acid, and carbonic acid happens to be the component in soda pop that makes the bubbles, carbonic acid immediately breaks down into water and carbon dioxide gas. Okay, and the way that works, let me sort of break this apart a little bit. The H2CO3, my two hydrogens are going to latch onto one of those oxygens. So if I pull two hydrogens and an oxygen off of that molecule, what I'm left with is a carbon and two oxygens. Okay, so there actually is a rhyme and reason to it. But noticing that when we have carbonic acid as a product, then it immediately breaks down into water and carbon dioxide. And that's actually how we get the bubbles in our soda pops. Sulfites and bisulfites do exactly the same thing. right? So if I have, again, HCl, hydrochloric acid, and this time some sodium bisulfite, NaHSO3. All right, HSO3 is bisulfite ion, okay? So I'm going to do double displacement again. So my sodium's going to go with the chlorine, my hydrogen's going to go with the bisulfite. So hydrogen with the bisulfite, sodium with the chlorine. So I get, as a product, basically the same thing as I did when I did my reaction with the carbonate, but this time I get H2SO3, sulfurous acid, and we get our salt, sodium chloride again. And my sulfurous acid is aqueous, as before. And again, it breaks apart. My two hydrogens pull off one of the oxygens, and I get H2O and sulfur dioxide this time. Okay, sulfites and bisulfites, sulfides, anything with a sulfur in it makes the most terrible smelling gas. Okay, so human flagellants has a fair amount of this and a fair amount of this. So not to put too fine a point on it, but that's what's coming out of our human bodies on a regular basis when we eat the wrong things. And we all know that it smells wonderful. So our fourth category is ammonium with base. All right, so if I have my ammonium compound, ammonium chloride, reacting with some sodium hydroxide, a good strong base. Again, we do a double displacement, so my ammonium is going to go with the hydroxide, and my sodium is going to go with the chloride. So one of my products is going to be ammonium hydroxide, and the ammonium hydroxide immediately breaks down in a similar way. So one of these hydrogens picks up with the OH, and again I get water. And what I'm left with, if I pull one of those hydrogens off the ammonium, is just NH3, which is ammonia gas. Okay, so this really does conclude our Chapter 4 lectures. And yeah, I promise it's over.